You know, every single day, probably dozens of times a day, you log in to something. You sign up for a new service, or you grant some app permission to access your contacts or photos. It feels totally instant, right? Just a click. But underneath that simple action is this decades-long story of evolving tech, brand new security threats, and some seriously clever solutions. Okay, let's dive in and really unpack the story of your digital identity.
So when you boil it all down, the problem seems ridiculously simple. A user wants to access a resource. That's it. So why on earth is this one of the most complex and, honestly, most difficult challenges in all of software engineering?
I mean, on a whiteboard, it's just a straight line, isn't it? You, the user, connect to the resource you want. Easy. But I have to tell you, this clean, simple little diagram, it's a complete fantasy in the world we live in today.
The reality? Well, it looks a whole lot more like this. It's what our source material calls the Cartesian product of complexity. And yeah, that's a fancy term, but look, that one simple line just explodes into this massive web connecting all these different apps, APIs, devices, and ways to prove who you are. This tangled mess is the real problem we have to solve.
So let's start right there. Let's break down exactly what makes this seemingly simple problem so deceptively complex.
You've basically got four major factors all crashing into each other. First, you have countless resource types, everything from old-school websites to modern APIs and serverless functions. Then you've got all the different development stacks that developers use, and they all handle things their own way. And what about identity sources? That's your Google account, your work login, maybe even a government ID. And finally, you've got this ever-growing list of client types, your phone, your laptop, your watch. Any real solution has to juggle all of this, all at the same time. It's a lot.
Okay, so to really get this, we've got to rewind the clock a bit. How did we first even try to solve this? Well, the story really begins with a simple password and a big, strong corporate wall.
In the first era, it was just pure chaos. You had a different username and password for every single application. And imagine if you left the company. Some poor admin had to go hunt down and manually delete every single one of your accounts. So the solution was the Directory. It centralized everything for what we call single sign-on, but it only worked inside the company's perimeter. To connect different companies, we needed something new, a protocol called SAML, which could safely jump across what the source calls the chasm of the public internet.
But, while the corporate world was busy building these bridges, the consumer web was facing a totally different, and you could argue, a much more dangerous problem. And it's a problem I guarantee you have personally encountered.
You've seen this before, right? Some new app wants to import your contacts, so it asks for your Gmail username and your password. And you type them in, and poof, it works. But what you've just done is hand over the keys to your entire digital kingdom. That app can now read your emails, it can delete your files, it can send messages pretending to be you, it can do anything it wants.
The takeaway here couldn't be simpler. Giving an app your main password is just fundamentally a terrible, terrible idea. That app now has way too much power, and let's be honest, it's never going to be as invested in protecting your password as your actual email provider is. This whole anti-pattern, it just had to be stopped.
And the solution that came to the rescue is one of the most important protocols on the internet today, OAuth 2.0. And the best way to think about it is not as the key to your house, but more like a digital valet key.
See, OAuth was built on this one single, really powerful idea, delegated authorization. It's basically a way for you to tell a service, like Google, hey, I authorize this other application to access some of my stuff, but only the specific stuff I say is okay. You are delegating permission without ever sharing your password.
And this valet key metaphor is just perfect. A real valet key can start the car and park it, right? But it can't unlock the glove compartment or pop open the trunk. It has limited, very specific permissions, or in tech terms, a limited scope. This is exactly what OAuth does for our digital lives.
So how does this magic work? Well, instead of asking for your password, the app literally sends you over to the actual service provider, like Google. There, you sign in securely, and then you see that familiar consent screen. This app would like to view your contacts. Is that okay? And when you click Approve, Google sends a temporary, one-time use code back to the app. Then, behind the scenes, the app trades that code for an access token. That's the actual valet key, which you can then use to access only what you approved.
This was a massive, massive leap forward. That whole password sharing anti-pattern was pretty much defeated. But a new problem started to pop up.
and it was born from a simple misunderstanding of what this powerful new tool was actually for.
And this brings us to the final piece of our modern identity puzzle, OpenID Connect, or OIDC for short. And it really comes down to the difference between having a key and having an ID card.
So developers started thinking, hey, if an app has a valid valet key, that must mean the user is who they say they are, right? So they started using that access token to actually authenticate users to prove their identity. This is a huge security flaw, and it's called the confused deputy attack, because the app is confused about what that token actually proves. It proves the app has permission to do something, not that the user is actually present and logged in. Okay, this right here is the most important distinction to understand in all of modern identity. OAuth 2.0 is for authorization. It answers the question, what can this app do? And it gives you the access token, our valet key. OpenID Connect is a thin layer built right on top of OAuth, and it's for authentication. It answers the question, who is this user? And it provides the ID token, your verifiable digital ID card.
Now this is what that ID token, which is also known as a JSON Web Token or JWT, actually looks like. I know it's a long, intimidating string of characters. It looks like nonsense, but I promise you it's actually a very, very clever, self-contained package of information.
And if we just decode it, we can see its anatomy. Each piece of information inside is called a claim. The IS is just the issuer, like Google. The OD is the audience. That's the specific app this token was issued for, which cleverly prevents it from being used anywhere else. Sub is the subject. That's your unique ID. And XP is simply the expiration time. It's basically a tamper-proof ID card that contains exactly what an app needs to verify who you are and nothing more.
So let's just put it all together one last time. The access token is the valet key. It's meant for a machine, an API, to go and unlock specific resources. The ID token is the ID card. It's meant for the application itself, for a human or a system to read it and confirm your identity. They are two completely different tools for two very, very different jobs.
And really, understanding this one distinction is the key to modern digital security. It's what's happening in the background, keeping your data safe every single time you click Login with Google. And it kind of leaves us with one last thought to chew on. Now that you know the difference, how many digital valet keys to your life have you actually handed out?